Today class
Good
is
evening, sir.
okay. Good evening. Today class is
Good evening,
about
sir.
basics of signals and systems. Same exam, important models. Okay, total 10 models are there in this class. This is the part one. Okay, in this part one, we discuss about the model 1 to 5. Okay,
Sir.
next. Okay, semester online class part one. Semester online class part one. Today, okay, subject is basics of signals and systems. Okay, basics of signals and systems.
Systems.
Okay, next. This is the unit one syllabus. In this unit one, you have total 3 models. Okay, we have three models. Already I shared the material. In each and every material, at last page, you have the models. Okay, models, important questions, and what are the important topics in the unit. Okay, in this unit, important model one. Model one is from basic operations on signals. Okay, in this one, you have model one. We have model 1. Okay, now we are going to discuss example 7 and 8 in the material. Okay,
Okay, sir.
next model 2. Model 2 is from elementary signals. Elementary signals. Okay, already we know what are the elementary signals. What are the elementary signals? Impulse signal. Next, step signal. Next, ramp signal and parabolic signal. These are the elementary signals. Another important also is there, sine, okay, sine wave and exponential, that like also is there, but these are the most important elementary signals. Okay, in exam, this is the main question. This is the main question. It have given what are the elementary signals and explain about the impulse and step response. Okay, you have to write both continuous and you have to write both continuous and discrete. Okay, this is very important. In each and every topic, you have to prepare both continuous signals and discrete signals. Okay, then only it is considered as a one question. Okay, in exam it may be given continuous or it may be given discrete. Okay, whereas in this impulse in this elementary signals, if a impulse step is given, you have to write impulse continuous, impulse discrete, step continuous, step discrete. Okay, that like next ramp continuous and ramp discrete, parabolic continuous and parabolic discrete. Okay, that like you have to write in the exam. Next, in this we have, this is the theory, and in problem, okay, we have model 2. We have model 2. Okay, that is overall these 5 units have 10 models. Okay, 10 models. First of all, you have to clear that 10 models, and next you have to prepare important questions, and next previous problems. Okay, previous papers. Okay, what is the order? First you have to complete
And models.
model 1 to 10. Next, important
Important
question.
questions.
Next, previous
Previous
papers.
papers.
Okay, this is the order.
Okay,
Okay,
sir.
that means in model 1 it may be 1 problem, 2 problems, or 3 problems. Okay, or it belongs to model 1 means it belongs to unit 1 or unit 2 or unit 3, that like. Okay, that means suppose in already we know in unit 2 and unit 4 has a same type of problems, that is impulse problems, so it comes under model 1. Okay, next, convolution. convolution is there. I'm telling just examples. Okay. Next, convolution. Convolution may be in unit 2, unit 3, unit 4, and unit 5 also. So it all comes under one model. Okay. That like we are discussing discussing these important models. Okay. So this is the basic operation signals as a model 1. There is no other problems, only problem 7 and 8. Next, second model has a elementary signal problem. Okay, that problems are model 2 has a example 9. Example 9. This is model 2. Next, model 3 in this unit only, that is in this system viewed as interconnection of operations and properties of system, you have model 3. This is model 3. Okay. We will discuss example 13 and example 14. Okay. In this material, we will discuss that 13 and 14. Totally for model 1, example 7 and 8. For model 2, example 9, and model 3, example 13 and 14. Okay. Now see here, this is the model 1. Okay. Model 1, basic operations on signals. In this is the theory. Okay. This is the theory and this is the problems. These are the problems. In this problem, 7 and 8 comes under model 1. Okay. Next, model 2. This model 2 comes under elementary signals. Okay, already we discussed it, but in material, this is the printed material. Okay, written material. I scanned each and every page. Okay, this is the scanned page. This is the last page of the unit 1. Okay, important points from unit 1. This is the last page from unit 1. So elementary signals has the model 2. This is the theory, and in problems we have model 2, that is example 9. Okay, next, in system interconnected classification, this is the theory, and in problems we have two types of problems. In these two types of problems, we discuss about the static, dynamic, okay, casual, non-casual, linear, non-linear, okay, time variant, time invariant. Okay, we have to find these values. Okay, we have to find these terms in example 13 and 14. So model 3 contains example 13 and example 14. Okay. So now see here, one difference up to here, that is up to model 2, these all belongs to signals. These all belongs to signals, whereas this portion belongs to systems. So in signals, we have periodic, aperiodic, casual, anti-casual. Okay, in signals. In system also, we have casual, non-casual, okay, linear, non-linear, same. Okay, for signals, we have casual, non-casual. For system also, we have casual, non-casual. Okay, this is very, very important. Signal means sine omega t. This is the signal. Cos omega t. This is the signal. Next, e power at. This is the signal. These are the signals. Next, system means y of t is equal to x of t plus 2xy plus 3. That like, okay, or differential equation d square y of ty dt square plus 3 y of t is equal to x of t. That like, okay. These are the systems, and these are the signals. Okay. Now we are going for a model 1. Okay. Model 1, example 7 and example 8. We are going for a example 7. Okay, this is the question, example 7. In this question, for signal x of t, okay, any signal, any input signal, we represent with the x of t, shows in the figure. That is, this is the diagram. Okay, in this diagram, x of t is given, x of t is given, and t is given, and also waveform also is given, signal is given. We have to find x of t minus 3, x of t plus 3 in first question. In second question, x of t plus 2, and this is the value. So in first question, two questions. In second question, two questions. In total, four questions. We have 8 problems. Okay. So see the concept. Here concept is very, very important. This concept is on a basic operations of the signal. Okay. What are the basic operations? Time, time, shifting, time, scaling, time, reversal, and so on. These are the main important. Okay, here for what is the first term? Time. Okay, here first term is the time. So time belongs to x-axis. So everything is in horizontal direction only. Okay, no vertical direction. The changes are made in a horizontal direction only. Okay, time shifting. Time shifting is t is replaced to t minus t naught or t plus t naught. Okay, next, time scaling. Time scaling is a into t or t by a. Okay, this is time scaling. Next, time reversal. T is replaced with minus t. Okay, t is replaced with minus t. Okay, in problem we can understand what is these are: time shifting, time scaling, time reversal. Okay, next, first question. What is the first question? X of t minus 3. Okay, x of t minus 3. This signal is called x of t. Okay, this signal is called x of t. So we have to shift this signal to 3. Remember, we have x of t minus 3. Whatever may be within the brackets, we have to equate to 0. That is, t minus 3 is equal to 0. Okay, to get the t value, we have to equate the 0. T is
హలో
equal to,
సార్
hello? Ah,
సార్ ఎవరో రిమూవ్ చేస్తున్నారు సార్.
ఈ రిమూవ్ చేయడం ఏంటయ్యా? ఒకసారి ఉండు. Okay, now there is no problem. Okay.
Okay,
థ్యాంక్
sir.
యూ.
Hmm. Now we have to equate this brackets term to 0. T minus 3 is equal to 0. Okay, t is equal to 3. Now what is the value of 3? What is the value of 2? Okay, what is the value of t? 3. Okay,
Yes, sir.
so here what is the value? 0. So this value should be shifted to 3 units. Okay, 3 units to right side. Okay, now see here, this is the same value. This same value shifted to 3 units right side. Okay, if it is t is equal to minus 3, it is shifted to left side. Okay, here t is equal to 3, that's why it is shifted to right side. Okay, here this is the simple one, but in exam you have to write a property. Okay, basic operation. What is the property? time shifting property. Okay, you have to write time shifting property. You have to mention these name. Okay, in this time shifting property, again we have two types. Okay, time advance and time delay. Okay, we have two types, time advance and time delay. Okay, what are those? Time advance and time delay. Okay, if this waveform is shifted to left side, then it is called advanced. If the waveform is shifted to right side, it is called delay. Okay, in time shifting, again we have two types. What are those? Time advanced and time delay. So remember like this: A is first letter, D is next letter. So first A comes and later D comes. Okay, left side A, right side D. So the waveform is shifted to left side, then it is called advanced. Waveform is shifted to right side, then it is called delay. Okay, what is here written here? So x of t is shifted to right side by 3 units. Okay, it is shifted to 3 units. Okay, here we can write a here we can write a comma, time shifting delay is applied. Okay, here what you writing, comma, here we are writing time shifting delayed by 3 units. Okay, delayed by 3 units. This is the waveform. Next, x of t plus 3. We are going for a next problem. Okay, we have to equate these brackets value. T plus 3 is equal to 0. T plus 3 is equal to 0. T is equal to minus 3. Minus 3 means it should be shifted to left side. Okay, how many units it is shifted? Minus 3, 3 units. So it is shifted to 3 units. Okay, it is shifted to 3 units. It is called a time shifting. In time shifting, you have two types. What are those? Time advanced and time delay. Left side is called advanced, right side is called delay. So here waveform is shifted to left side, hence it is called advanced. Okay, time shifting advanced. Okay, on applying time shifting advanced, the waveform is shifted 3 units left side. Okay, ఈ పాయింట్ అర్థమైందా?
Yes, sir.
Okay, next second one, first option. Okay, second law first the 2t plus 2, 2t plus 2. Now we see 2t plus 2. See here 2t plus 2. Okay, what is the first step you are doing? Equate the value in the brackets. Okay, here what is the value in brackets? 2t plus 2. So 2t plus 2 is equal to 0. T is equal to minus 2 by 2, that is equal to minus 1. So what is the value of t value? Minus 1. So for x of t plus 2, first advance. Okay, why it is advance? Advance అని ఎందుకు చెప్పాం? Because waveform is shifted to left side. Minus 1 కదా. ఓకే, మైనస్ 1 కాబట్టి ఏమైంది? వేవ్ ఫామ్ లెఫ్ట్ సైడ్ షిఫ్ట్ అవుతుంది. ఓకే, లెఫ్ట్ సైడ్ షిఫ్ట్ అవుతుంది. ఇక్కడ చూడండి, లెఫ్ట్ సైడ్ కి ఇది ఒరిజినల్ వేవ్ ఫామ్. ఓకే, ఎక్స్ ఆఫ్ టీ ఒరిజినల్ వేవ్ ఫామ్. ఈ ఒరిజినల్ వేవ్ ఫామ్ ఏం చేసాం? -1 అంటే ఇక్కడ చూడండి, ఇక్కడ ఏమన్నాడు? ఎక్స్ ఆఫ్ టీ అడ్వాన్స్డ్ ఎక్స్ ఆఫ్ టీ టు లెఫ్ట్ సైడ్ by 2 units, and then time using scale compression compressed the x of t by the factor 2. ఇక్కడ ఎందుకు ఇలా వచ్చింది? సరే, ఒకసారి మెటీరియల్ చూస్తాను. ఏజ్ నెంబర్ 21. ఓకే, ఇక్కడ ఏంటంటే కాన్సెప్ట్, whenever we have only values like t+2, t-3, ఓకే, ఇక్కడ కోషంట్ ఉండకూడదు. ఓకే, ఇక్కడ కోషంట్ ఉండకుండా ఓన్లీ t+2, t-2 అలా ఉంటే ఈక్వల్ టు 0 చేయొచ్చు. ఓకే, ఇక్కడ ఏమైంది, కోషంట్ ఉంది కదా, కోషంట్ ఉంది కాబట్టి మనం ఫస్ట్ ఏం చేస్తామంటే we have to take rightmost value. ఓకే, we have to first solve rightmost value. rightmost value ఎంత, +2. ఓకే, +2 అది ఈక్వేట్ చేస్తే ఇది ఏమైంది, left side by 2 units. ఇది ఈక్వేట్ టు 0, దట్ ఈస్ 2t + 2 is equal to 0. 2t is equal to -2. ఓకే, -2 వచ్చింది కదా. ఓకే, -2 వచ్చింది కాబట్టి ఏమైంది, the waveform should be shifted to left side. ఓకే, -2 కదా, x is equal to -2, hence the waveform should be shifted to left side. ఓకే, అంటే ఈ పోర్షన్ 2 యూనిట్స్ లెఫ్ట్ సైడ్ జరుగుతుంది. చూడండి, ఫస్ట్ ఎక్కడ ఉంది వాల్యూ, 0 దగ్గర ఉంది. 0 దగ్గర ఉన్న వాల్యూ ఎక్కడ షిఫ్ట్ అయింది, -2కి షిఫ్ట్ అయింది. 0 దగ్గర ఉన్న వాల్యూ -2కి షిఫ్ట్ అయింది. ఓకే, ఇక్కడ మనం వేవ్ ఫామ్ ని కంప్రెస్ చేయట్లేదు, అలాగని చెప్పి స్ట్రెచ్ చేయట్లేదు. వేవ్ ఫామ్ ఎలాగుందో అదే వేవ్ ఫామ్ ని లెఫ్ట్ సైడ్ జరిపాం అంతే. ఓకే, లెఫ్ట్ సైడ్ జరిపితే అది అడ్వాన్స్డా లేదంటే డిలేనా,
అడ్వాన్స్డ్
కాబట్టి లెఫ్ట్ సైడ్ జరిగింది కాబట్టి అడ్వాన్స్డ్. ఈ పోర్షన్ అయిపోయింది కదా, +2 పోర్షన్ కంప్లీట్ అయిపోయింది. ఇంక మిగిలింది ఏంటి, 2t. ఓకే, ఇక్కడ 2t ఉంది కాబట్టి ఇక్కడ కోషంట్ ఉన్నప్పుడు మనం ఏం చేస్తామంటే 2t ఈజ్ ఈక్వల్ టు 1 పెడతాం. ఓకే, దీన్ని దేనికి ఈక్వేట్ చేస్తాం, ఇలా కోషంట్ ఉంటే 2t ఈజ్ ఈక్వల్ టు 1. ఆల్వేస్ వెన్ అవర్ కోషంట్ ఈస్ దేర్ వీ హావ్ టు ఈక్వేట్ టు 1. 2t ఈజ్ ఈక్వల్ టు 1, t వాల్యూ ఎంత అవుతుంది, 1/2. ఓకే, అంటే ఈ వాల్యూస్ మొత్తం కూడా మనం డివైడెడ్ బై 2 చేయాలి. -1 ఇంటూ 1/2 అంటే ఎంత అయింది, 0.5. 0.5 వచ్చిందా. నెక్స్ట్ -2 ఆఫ్ చేయండి, సగం చేయండి, ఎంత, -1. -3 ఆఫ్ చేయండి, ఎంత, -1.5. ఓకే, -1.5. ఇప్పుడు దీన్ని ఏమంటాం మనం, కంప్రెస్డ్ విత్ ఫ్యాక్టర్ 2 అంటాం. కంప్రెస్ అయింది కదా, వేవ్ ఫామ్ కంప్రెస్ అయింది కాబట్టి ఇది కంప్రెస్డ్ అంటాం విత్ ఫ్యాక్టర్ 2. ఇక్కడ అప్లై చేసే ప్రాపర్టీ పేరు ఏంటంటే టైం స్కేలింగ్. ఓకే, ఈ ప్రాపర్టీ పేరేంటి, టైం స్కేలింగ్. ఇక్కడేమో టైం స్కేలింగ్ అప్లై చేసాం, ఇక్కడేమో టైం షిఫ్టింగ్ అప్లై చేసాం. చూడండి, ఇక్కడ టైం షిఫ్టింగ్ అప్లై చేసాం, అందులో ఏంటి, టైం అడ్వాన్స్. ఇక్కడ చెప్పండి
ఇంగ్లీష్ ప్లీజ్.
ఇంగ్లీషా, ఓకే ఓకే ఓకే. Here this waveform is shifted to left side by units 2. Here +2 is equal to 0, that is -2. Okay, so -2 means left side. Okay, -2 means left side. Okay, how many units, 2 units.
2 units.
So this is, let it be, this is the value. Okay, at x is equal to 0, this is the value. This value should be shifted to left side 2 units.
2
okay,
units.
2 units, 1 2 units. Okay, it is shifted. This is called time shifting. In time shifting, what you call left side is called time advanced. Okay, time advanced shifting. This is completed. Next +2 is completed. What is the next one, 2t. Okay, 2t is equal to 1. We have to equate to 1, so t is equal to 1/2. Okay, so every value should be multiplied with 1/2. So -1 into 1/2, how much value, -0.5. Next -2 into 1/2, how much value, -1. Next -3 into 1/2, that is -1.5. Okay, so original values are 1 2 3, and here obtained values are 0.5 1 1.5. so it is compressed. Okay, so it is called compressed. Here property we use called time scaling. Okay, time scaling. In this time scaling we have 2 types. One is compressed and second one is expansion. Okay, compressed and expansion. Here what we have, compressed. So compressed. Now this property is called time scaling compressed with factor 2. Okay, here what is the factor? 2. So with the factor 2. Okay, this is the first problem completed. Next, second problem. Now second problem. Here what is the second problem? 1 by 2 into t minus 2. Now here minus 2 is equal to 0. That is t is equal to 2. Okay, t is equal to 2. Every time you have to write a original signal. Okay, every time you have to write original signal. That is x of t. So this is the original signal x of t. How many units it is shifted? 2 units. Okay, to right side or left side?
Right side, sir.
Right side. How we can say that right side? Minus 2. It is equal to 0 plus 2. So it is shifted to right side. This is the original signal. This signal is shifted to 2 units. See here, shifted to 2. Okay. Now this is called x of t minus 2. Here x of t. Here it is called x of t minus 2. Now this is called time shifting. In time shifting, what is this one called? Delay or advance?
Delay.
Delay. Okay, right side means delay, left side means advanced. Okay,
Advanced.
left side is A and right side is D. Okay, so this portion is completed. Next, what is the portion? 1 by 2 into t. You have to equate to 1. So 1 by 2 into t is equal to 1. What is the t value? 2.
2.
Okay, so every value should be multiplied with 2. 1 into 2, 2.
2.
2 into 2, 4.
4.
3 into 3, 3 into 2, 6.
6.
4 into 2, 8. Now here, time scaling, it is called time scaling, this property, and it is the expansion. Okay, previously it is compression, now it is expansion. Okay, now what is the property used here? Time scaling. In time scaling, what is the property? Sub-property?
Expansion.
Time expansion. Okay, so here is time compression, here is time expansion. Here is a time advanced, here time delay. Okay, these
Yes,
two
sir.
are called one property and these two are called one property. Okay, these two are called which property? Time shifting.
Time out.
This property is called time scaling.
Scaling. Time scaling.
Right. In time shifting, you have advanced and delay. In time
Time
scaling, you
advanced.
have
Time delay.
compressed and expansion. Okay, this is the first problem and it is the very, very important problem. So we take it as a model 1. Okay, this is model 1. The remaining
sir.
you can do now. Okay, 26 or
Yes, sir.
27 or
27, sir.
27. Okay, now 27. Tell me this answer. Is there any plus 2 minus 2? No. So here we have coefficient. Whenever we have coefficient, we have to equate to 1 or 0.
2. 1.
To 1. So
Equal to
5 by 3
1.
t is equal to 1. Now what is the value of t? 3 by 5.
3 by 5.
Okay. So see here, t is equal to 3 by 5. So every value, this is x of t. This is the original signal. This original signal, every value is multiplied with the 3 by 5. Okay. Minus 1 into 3 by 5. How much value? Minus 3 by 5.
Minus 3 by
0. Here 3 by 5. Here 2 into 3 by 5, 6 by 5. Okay,
6 by
complete.
5.
Next, 3 by 5 into t. Now what we have to do?
We have to equate to 1.
Equate to 1. Now what the value of t?
5 by 3.
5 by 3. Okay, so every value should be multiplied with 5 by 3. But here we have to write, it is time scaling. Okay, x of t by a factor of 5 by 3. That is by compressing a signal. This is written for first one. Okay, first one, compressing the signal x of t by 3 by 5. Okay, same for this one you have to write. For this one,
Yes.
it can be obtained by time scaling x of t by factor. What is the factor? 3 by 5.
Oh.
3 by 5. That is here expansion or depression. Expansion
Expansion.
or compression. Expansion. Okay, expansion
Expansion.
the signal x of t by 5 by 3. Because 5 by 3 is greater. Okay, here 5 by 3. 5 by 3 means what is the value? 0.6. 0.5 by 3. Okay, 5 by 3, what is the value? 5 by 3. 1.33. So greater than 1. So it is expand. Okay. Next. Model 1 completed. 7th problem completed. Now see this D. Now we will see the D. Up to now, we discussed about the only two operations. One is time shifting, and second one is time scaling. Third one is also there. What is the third one? Time reversal. Okay. Time reversal. This is the problem. Okay. X of minus t plus 2. X of minus t minus 2. Okay. Now see here. Here there is no coefficient. Now see here. There is no coefficient. Here also there is no coefficient. Only negative value is there. So first step is we have to equate to 0. Now see what way it happened. First obtain the time reversal and then shift the time signal to right side. Okay. So here first of all we have to give the preference to minus. Okay. Whenever these problem having a minus t plus 2, we have to give the preference to minus t only. Okay. Next you have to go to plus 2. Okay.
Yes, sir.
So here minus t is called a time reversal. Okay. Time reversal means if you have 1, in time reversal it is minus 1. If you have 2, time reversal minus 2. If you have 1 by 2, time reversal minus 1 by 2. Okay. If you have a value in right side, it will be go to left side. Now see, here we have only minus 1. So what is the value we have? That will be shifted to left side. If it is in the left side, it is shifted to right side. Now this is the original value. See here, this is the original value. That is original signal. In this original signal, minus 1. Minus 1 is shifted to plus 1. See here. Okay. Next, plus 1. Plus 1 is shifted to left side. Minus 1. Next, plus 2 is shifted to left side. Minus 2. Okay.
Yes, sir.
So this waveform will be like a mirror image. Okay. When we put here one mirror, same like the mirror, these two images will be there. Okay. So this is called time reversal. Next, what is the remaining portion? Minus t is completed. What is the remaining portion? Plus 2.
Plus 2.
Okay. So completely we have to make it 0. So minus t plus 2 is equal to 0. T is equal to 2. Okay. T is equal to 2 means shifted to right side or left side?
Shifted to right side.
Right side. So right side by 2 units. So this is called time delay. Okay. Right side means time delay. Left side means time advanced. Okay. So same what do we say? Same graph. Okay. It is shifted to 2 units. So here minus 2. Here we have minus 2. This should be shifted to right side. So it will come to 0. Okay. See here. It will came to 0. Okay. To 0. Next problem. Next problem is minus t minus 2. Already, how we can divide this problem?
You said by minus t.
Part 1 is minus t and part 2 is this total value should be equal to 0. Minus t is equal to 0. T plus 2 is equal to 0. T is equal to minus 2. Okay, that is the part 2. Already minus t we obtained. Okay, previously we obtained minus t. Okay, now remaining portion is t is equal to minus 2. So these waveforms should be shifted to left side. Okay, that means minus 2 should be shifted to minus 4. Minus 1 is shifted to minus 3. 0 is shifted to 2. 1 is shifted to 1, minus 1. Okay, this like you have to write in the exam. So it is shifted to left side. This is called time advance. Okay, this is shifted to right side. This is called time delay. Okay, right side means time delay, left side means time advance. Okay, left side A and right side D. A means advanced, D means delay. What this property called?
Time.
This property is called time shifting. Okay, what this property is called?
Time scaling.
This one, x of minus t.
Time reversal.
Time reversal. Okay, now what is this property called?
Time scaling.
Time scaling. Okay, these three are very, very important in every unit, every topic. These three are very, very important. Okay, this is the model 1. Model 1 completed. Now okay, next model 2. Next going for model 2. What is the model 2? Model 2 is elementary signal problems using properties and operations. Example 9. Example 39. Model 3. This is model 9. Model 2. Model 2 means elementary signals operations. Example 9. Okay. Example 11. This problem is based on the elementary signals. What are the elementary signals? Impulse, step, ramp, and parabolic.
Parabolic.
Okay. So 13, 14. Example 1 now. Convolution. Okay. Yeah, maybe. Once wait. Okay. Now, model 2. Model 2, example 9. Okay. It is on a elementary signals. Elementary signals. Okay. Here, first question given, u of minus t plus 2. Okay. You have to sketch the graph. You have to sketch the graph. Okay. In previously, already graph is given. That is, signal is given. You have to shift or compress or expand, or you have to time reversal the signal. But here, no signal is given. Only no graph is given. No graph is given. Only signal is given. Sorry. Already we know what is u of t. What is u of t? We signal in elementary signals. We signal u of t is called
Unit signal.
unit signal.
Unit signal.
That is a unit step signal. Okay. This is the graph. Okay. This is u of t. This value is 1. This is t. This is t greater than 0. So we have to take this as the original waveform. Okay. This is the original waveform. For this original waveform, we have to do this minus t plus 2. Okay. In previously, whenever you have we got minus t, first preference given to minus t. Next, second preference given to plus 2. Okay. So first you have to go for u of minus t. Okay. U of minus t is called
Time scaling.
Time reversal.
time reversal. Okay. So this is the original waveform u of t, and this is a time reversal. So this will be reverse. Okay. If x value is 1, minus 1. X value is 2, minus 2. Okay. If there is no x value, the waveform is right side. It will be shifted to left side. Okay. So it is called u of minus t. So minus t completed. Next, plus 2. Okay. Minus t plus 2 is equal to 0. Now t minus 2 is equal to 0. T is equal to 2. Okay. T is equal to 2. So we have to shift this waveform. We have to shift this waveform 2 units right side. Okay. You have to shift this waveform 2 units right side. Okay. Here this value is 0. So this value will be 2. Okay. Now what is value? U of minus t. This value is minus t. How many units is shifted? Plus 2. Okay. So plus 2 units is shifted. It is shifted to right side. So this is called time shifting. Time shifting. What is this value called? Time shifting delay. Okay. If the signal is shifted to right side, it is called delay. If it is shifted to left side, it is called advanced.
Advanced.
Okay, same properties, but here signal is not given only expression. With this expression we have to find which signal in elementary signals. Okay, and from these elementary signals we have to find a basic signal, and from the basic signal this is taken as a original signal. So this original signal is shifted according to question given. Okay, next, second question. Second question is given minus 2 u of t plus 2. Okay, here u means u of t. U of t means which signal? Unit
Signal.
step signal. Okay, so we have to take a unit step signal. So this is the unit step signal u of t. Okay, u of t. Here what is the y value? 1. Now what we have to do? First we have to find this value. Here it is minus t, no minus t. Okay, so you have to go direct value, that is t plus 2 is equal to 0. Now t is equal to minus 2. Okay, so you have to shift this waveform 2 units to which direction? Left side or right side?
Left side.
Left side. So this value will be shifted to left side. How many units?
Minus 2.
2 units. So minus 2. Now u of t will become u of t plus 2.
Minus 2.
Okay, అదే t plus 2 ని ఈక్వేట్ చేస్తే ఎంత అవుతుంది? minus 2 అవుతుంది. Okay, next, this portion is completed. Next is coefficient. How much coefficient? minus 2. Okay, so multiply with the minus 2. Here what is the value? 1. Okay, multiply with the minus 2. So this will be shifted in reverse direction. Okay, here same minus 2, but this 1 is shifted to minus 2 because how much value you have to multiply? minus 2.
Minus 2.
Okay, so u of t plus 2 becomes minus 2 u of t plus 2. Okay, for every waveform here we have to write what we are going to do. Okay, very important. Here time is shifted to left side. So what is this one called? Time advanced. Time advanced by 2 units, or it is shifted to left side. It is shifted to left side by 2 units. First of all, you have to what we have to write? It is shifted to left side by 2 units and it is called time advanced by 2 units. Okay, for each and every waveform you have to write one single point compulsory. Okay, next, third one. Here third one, minus 4 into r of t. What is r of t called?
Ramp.
R of t, unit ramp signal. Okay, unit ramp signal, and this is the ramp signal. Here what is the value? 1. Here also what is the value? 1. Okay, in brackets, that is for a time there is no shifting. Okay, time ki shifting ante em ledhu. Only coefficient. Okay, so how much coefficient? -4. Okay, so -4. -4 అంటే ఎలా వస్తుంది? దిస్ ఇస్ ది -4. ఇదే కదా -4. -4. This is positive slope. Here also positive slope. So -4, 4. This is called -4 into R of t. Simple.
సార్ ఎక్స్ యాక్సిస్ వాల్యూ చేంజ్ అవుతుంది కదా సార్?
Huh?
ఎక్స్ యాక్సిస్ వాల్యూ అలాగే ఉంటుంది సార్, 1 ఉంటుంది సార్, లేకపోతే అది కూడా 4 అవుతుందా?
అది కూడా 4 అయ్యే ఛాన్స్ ఉంది. లేదంటే ఇంకా ఎక్స్ వాల్యూ రాయకండి, అలా వదిలేసేయండి. ఓకే
ఓకే సార్.
Only you have to show the y value -4. That's it. Okay. Here model 2 is completed. ఈజీగా ఉన్నాయా?
ఈజీయే సార్.
అర్థమవుతున్నాయి సార్.
ఓకే, నెక్స్ట్ మోడల్ 3.
ఉన్నాయి సార్.
This is the question. Model 3, this is the question. ఇది కొంచెం జాగ్రత్తగా వినండి, ఇది కొంచెం కష్టంగా అనిపిస్తుంది. మోడల్ 3. ఓకే, ఇప్పటిదాకా ఏం చెప్పుకున్నాం? Up to now we have discussed about the only signals. Now from here this topic is for only system. Okay, our concept is signals and systems now. So here concept is system. That means we have equations like this. These equations are called systems. Okay, system equations, or these are called LTI. Okay, what is this is called? LTA, linear time invariant. Okay, these are called systems or LTI. Now what we have to find? Check whether the following systems are static, see here, static or dynamic, linear or non-linear, casual or non-casual, time invariant or time variant. Okay, we have to check these 4 conditions for each and every question. Okay, first of all you have to check for we are checking for A, B, C. Okay, for remaining you do yourself. Okay, now A is what is the order of A? Order of A is 3. Here one important point I want to tell regarding this one. Here we consider values, that is past, present, and future. Okay, what are the values? Past, present, and future. If it is y of t, that is present value. If it is t plus 1, that is future value. If it is t minus 1, that is past value. Okay, that is, these points are very, very important. Okay, what are the points? X of t, y of t, only t means present. T minus 1 means past. T plus 1 means future. Okay, here t minus 4 belongs to
Past.
N minus 2 belongs to
Past.
N minus 1 belongs to
Past.
Okay, remember these points. If you know this concept, this is very, very easy. Okay, next. Now checking for the first one. Now see here, checking for the first one. What is the first one? Whether it is static or dynamic. Okay, for first question, First one, you have to check for the static or dynamic. Okay. See here, the system is described by a differential equations, hence it is dynamic. If you have any differential equations, then it is called a dynamic system. Simply. Okay. Simple, we can say that. Next, what is second one? 13th color. Okay. What is the second one? We have to check for the linear, non-linear. Okay. You have to check for a linear, non-linear. See here, linear, non-linear. What is the answer? We got a non-linear. Okay. So what is the condition? Here, condition is every value should be written in this form only. See here, value. Ante linear ga, linear ante ikkada ardham entante we have to apply superposition theorem. Okay. What is superposition theorem? Total current is equal to individual currents. Okay. Here also, okay, y1, y2, a into y1 plus b into y2. Here also, a into y1 plus b into y2, a into y1 plus b into y2. But see here, here we got a y1 square plus y2 square. Since one term in the LHS is not a weighted sum, okay, that means this value, okay, that means this value, sum of the, what is this called, is not a weighted sum of outputs. Okay, weighted sum of outputs. See here, y1, y2, y1, y2. Here, y1 square plus y2 square. So squares cannot be allowed. So it is a not the linear. So it is called a non-linear. See here, since one term in LHS is not the weighted sum of the outputs, the superposition theorem principle is not valid. Hence, the system is non-linear. Okay, got it?
Sir,
Sir, repeat once.
Okay.
I equation ఎలా వచ్చింది సార్
Question okay, first take this equation. Okay, now take this equation. Equation 1. This is the equation 1. Okay, put the equation y1, 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 x1. Next, take the same equation. Take the same equation again. Now put y2, 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 x2. Okay. Now we have two equations. In these two equations, first equation has y1, second equation has y2. Here y1, y2, y1, y2, y1, y2, x1, x2. Okay. Now what is the condition? A y1 plus b y2. This is the condition. ఈ ఫామ్ లో తీసుకురావాలి. ఓకే, హియర్ ఏ అండ్ బి ఆర్ ది కాన్స్టెంట్, సమ్ వాల్యూస్. ఇక్కడ 2, 4 ఇచ్చాడు కదా, ఏదైనా అనుకోండి వాల్యూస్, నో ప్రాబ్లం. ఓకే, ఫస్ట్ హియర్ d క్యూబ్ d క్యూబ్, dd క్యూబ్ dd క్యూబ్. ఇక్కడ ఎంత ఉంది? y1. సో a ఇంటూ y1. నెక్స్ట్ దంట y2, b ఇంటూ y2 ప్లస్ 2 2 d స్క్వేర్ d స్క్వేర్. నెక్స్ట్ y1 a y1, y2 a y2, b y2. ఓకే, అంటే ఇక్కడ ఏ బి అనేవి కాన్స్టెంట్స్, అది మామూలుగా వస్తాయి, అది ఫార్ములా అంతే. ఓకే, నెక్స్ట్ 4 4 dy dt. ఓకే, dy dt. నెక్స్ట్ y1 a y1. ఇక్కడ నెక్స్ట్ ఈక్వేషన్ ఏముంది? y2 a y2. నెక్స్ట్ 3 3. నెక్స్ట్ y స్క్వేర్, అంటే ఇక్కడ ఎంత ఉంటుంది? y1 స్క్వేర్ a y1 స్క్వేర్ ప్లస్ ఇక్కడ ఎంత ఉంటుంది? y2 స్క్వేర్. సో ప్లస్ b y2 స్క్వేర్ ఈజ్ ఈక్వల్ టు ఇక్కడ x1 అంటే ఏమని రాసుకుంటాం? a x1 ఆఫ్ t ప్లస్ 1. నెక్స్ట్ ఈక్వేషన్ x2 ఉంటుంది. x2 అంటే b x2 ఆఫ్ t ప్లస్ 1. ఓకే, పాయింట్ గాట్ ఇట్?
Yes, sir.
ఓకే, ఇక్కడ మనకి ఈక్వేషన్
Yes,
ఏంటి, ఎవ్రీ టర్మ్ షుడ్ కంటైన్స్ ఓన్లీ నార్మల్ వాల్యూస్ ఓన్లీ. ఇక్కడ స్క్వేర్లు కానీ క్యూబ్లు కానీ రాకూడదు. ఓకే, ఇక్కడ నో స్క్వేర్ నో క్యూబ్, సో దిస్ ఈజ్ ఓకే. నెక్స్ట్ no square no cube, this is also okay. Next no square no cube, this is also okay. Now see here, y square y1 square y2 square, square lo vachinayi kada. Whenever you got squares, then it is not valid for superposition theorem. Okay, superposition theorem is not applied. Why? Because square means it is non-linear. మనం నేర్చుకున్నాం కదా నెట్వర్క్స్ లోని, in a linear bilateral network. So when you got square terms, it is not the linear bilateral network. Okay, so with this term it is violates the superposition theorem, hence it is non-linear. Okay, ante meeku ee equation చూడగానే అర్థమైపోవాలి. Here only y is given, so this term is okay. Here y is given, this term is okay. Here y is given, this term is okay. Here y square is given, so here only we can say that this is non-linear. Okay.
Okay, sir.
Next, so this system is non-linear. Now third one. What is third one? Third one is very easy. Casual, non-casual. Already in signals we have a casual. Casual means right side. We have only right side waveform, then it is called casual. If you have only left side waveform, then it is called anti-casual. If we have waveform on left side and right side, then it's called non-casual. Okay, adi signal lodi. But here for system we will see the future values. Okay, inda మనం అనుకున్నాం what are past values, present values and future values. What are past values? X minus 1. What is present value? X of t. What is future value? X of t plus 1. Okay, now in this equation now see here, in this equation here we have y of t. Y of t means present value. Y of t means present value. Y of t present value. Ikkadi t present value. T plus 1. T plus 1 means future value.
Future.
Okay, so if a system is depends upon future value, then the system is non-casual. Okay, మరి casual అంటే ఎలా సార్ అంటే, if the system depends only on present and next previous values. Okay, present and future previous values, then this is called casual. Okay, ఇక్కడ ఎన్ని టర్మ్స్ ఉంటాయి? Here we have only two terms, non-casual and casual. Okay, so for non-casual, if you have future terms, then it is called non-casual. If you have only present and past, then it is called casual. Got it? చూడండి ఇక్కడ రాస్తాను.
Yes, sir.
If x of t and x of t minus 1, then this is called casual. If we have x of t minus 1, and if we have only one x of t plus 1, ఒక్కటి ఉన్నా సరే ఇవేనా ఉండేవండి. Okay, if you have only one t plus 1, then it is non-casual. Okay, here we have only one future value, this is called future value. So if it has only one future value also, this is called a non-casual. Okay, x of t means
మైనస్ ఉంటే
present.
క్యాజువల్ సార్.
Minus unte
Future
casual.
unte
Suppose if it is t minus 1,
Then
then it is
non-casual.
casual. Okay, మొత్తం terms లో if we have only one future term, that is t plus 1, then it is called non-casual. Okay, x of t minus 1, this is past. Okay, if the system has, if the system has present and past, then it is called casual. Okay, if the system has future value, t plus 1 means it is future. Okay, it is future, then it is called non-casual. సార్ మరి నాన్ క్యాజువల్ కి ఎక్స్ ఆఫ్ టీ మైనస్ 1 ఉండొచ్చా సార్ అంటే ఉండొచ్చు. ఓకే, అప్పుడు ఏమవుతుంది? ఫర్ నాన్ క్యాజువల్ ఇట్ హ్యాస్ ప్రెసెంట్, పాస్ట్ అండ్ ఫ్యూచర్. ఇట్ హ్యాస్ త్రీ టర్మ్స్. ఇఫ్ it has 3 terms, then it is called non-casual. Okay, if it has only 2 terms, that is present and past, then it is called casual. Okay, next, fourth one ఏం అడుగుతున్నారు? టైమ్ ఇన్వేరియంట్ ఆర్ టైమ్ వేరియంట్. టైమ్ ఇన్వేరియంట్ ఆర్ టైమ్ వేరియంట్. How you know whether it is invariant or not variant? All the quotients of the differential equation are constant and the system is time invariant. Okay, here what are the quotients? దీని కోఎఫిషియంట్ ఎంత? 1. దీని కోఎఫిషియంట్ ఎంత? 2. For this one quotient 4. For this one quotient 3. For this one quotient 1. So every quotient is a number, finite number. Okay, so this is called a time invariant. Okay, so finally the given system is dynamic. Okay, first condition is dynamic, second condition is non-linear, and third condition is non-casual, and fourth condition is time invariant. Okay, this is one of the important problem. Okay, next.
నెంబర్స్ ఉంటే అన్ని ఇన్వేరియంట్ టైమ్ ఇన్వేరియంట్ వస్తుంది సార్.
టైమ్ ఇన్వేరియంట్. సపోజ్ ఇక్కడ 4 ప్లేస్ లో y ఉందనుకో, 4 ప్లేస్ లో y ఉందనుకో, అప్పుడు ఏంటి? వేరియబుల్ కదా, వేరియబుల్ కాబట్టి నౌ ఇట్ ఈస్ టైమ్ వేరియంట్. ఏమైనా నా మాటలు నాకే వినపడుతున్నాయి?
అదే సార్.
ఓకే, నెక్స్ట్. ఇప్పుడు దీన్ని చెప్పండి, చూద్దాం. ఫస్ట్ వన్ స్టాటిక్ డైనమిక్. స్టాటిక్ డైనమిక్ అంటే ఇప్పుడు హ్యాస్ డిఫరెన్షియల్ ఈక్వేషన్స్, ఆటోమేటిక్లీ ఇట్ హ్యాస్ డైనమిక్ నేచర్. ఫస్ట్ వన్ కంప్లీటెడ్. సెకండ్ వన్ ఏం చెప్తున్నారు? ఏమడుగుతున్నాడు? సెకండ్ వన్ లీనియర్ నాన్ లీనియర్ అడుగుతున్నాడు. నాన్ లీనియర్ ఎలా తెలిసింది? సూపర్పొజిషన్ థియరం ని ఇది యాక్సెప్ట్ చేయాలి. సూపర్పొజిషన్ థియరమేనా? కాదు, నాన్ లీనియర్. ఇదేంటిది? కరెక్ట్, లీనియర్ నాన్ లీనియర్. ఇక్కడ ఏంటిది? y1 y2, ఇక్కడ y1 y2, ఇక్కడ y1 y2, నెక్స్ట్ y2, నెక్స్ట్ ఇక్కడ y2 y2. ఇక్కడ చూడండి, ఇక్కడ 2 into y of t ఉంది కదా, 2 into y of t, 3 into t. ఇక్కడ చూడండి, ఇక్కడ తెలిసిపోతుంది. రెండు ఈక్వేషన్స్ ని కామన్ తీస్తే డి స్క్వేర్ కామన్ తీస్తే ఇక్కడ ఏమైంది? ay1 ప్లస్ by2. దిస్ ఈక్వేషన్ ఈస్ ఓకే. నెక్స్ట్ ay1, ఇక్కడ చూడండి, ay1 ప్లస్ by2 ఉండాలి. నో డిఫరెన్షియల్ ఈక్వేషన్ షుడ్ బి అలౌడ్. ఆల్రెడీ ముందే తీసుకుంటాం, డి స్క్వేర్ బై డి స్క్వేర్ అనేది ముందే తీసేసుకుంటాం. ఓకే, బిఫోర్ ఓన్లీ వీ విల్ టేక్ దిస్. ఓకే, in place of y1, ay1 plus by2. Okay, in place of y1, ay1 plus by2. What here? This happened here. This value has a y1, so not a weighted sum of outputs. Second term, ఇక్కడ సెకండ్ టర్మ్ చూడండి, 2 into y. ఇక్కడ y అనేది వేరియబుల్ కదా, ఆల్రెడీ ఇక్కడ dy by dt అనేది వేరియబుల్ ఉంది. ఓకే, we have second variable, so it cannot be a linear. Okay, got it?
Yes, sir.
ఇలా రాసినప్పుడు ఏమంటాం, పేరు ఏమంటాం, నాట్ ఏ వెయిటెడ్ సమ్ ఆఫ్ అవుట్పుట్. ఇలా రాయాలి మన ఎగ్జామ్ లో, నాట్ ఏ వెయిటెడ్ సమ్ ఆఫ్ అవుట్పుట్స్ అని రాయాలి. అంటే ప్రాబ్లం ఇక్కడ వచ్చింది కాబట్టి ఇట్ ఈస్ నాన్ లీనియర్. ఇంకోటి ఏంటిది, ఇట్ క్యాన్ వెన్ ఇట్ ఈస్ సమ్ నాట్ వెయిటెడ్ సమ్ ఆఫ్ అవుట్పుట్స్, సూపర్పొజిషన్ ప్రిన్సిపల్ ఇస్ నాట్ అప్లైడ్. ఇది పాయింట్ రాయాలి, ఈ 2 పాయింట్స్ రాయాలి ఖచ్చితంగా. నాట్ వెయిటెడ్, సూపర్పొజిషన్ థియరం కెనాట్ బి వ్యాలిడ్ ఆర్ సూపర్పొజిషన్ కెనాట్ బి అప్లైడ్. నెక్స్ట్ థర్డ్ వన్, క్యాజువల్ నాన్ క్యాజువల్. క్యాజువల్ నాన్ క్యాజువల్ అంటే ఎలా చెప్తాం?
If we have future, then it is non-casual.
y of t అంటే ప్రెసెంట్, ఇక్కడ y of t అంటే ప్రెసెంట్, t y of t అంటే ప్రెసెంట్, x of t అంటే ప్రెసెంట్. మొత్తం ప్రెసెంట్ లోనే ఉన్నాయి, ఫ్యూచర్ ఏం లేదు ఇక్కడ. ఫ్యూచర్ ఏం లేదు కాబట్టి
So it is casual.
ఓకే, ఇక్కడ ఏం రాసి చూడండి, ది అవుట్పుట్స్ డిపెండ్స్ ఆన్ ప్రెసెంట్ ఇన్పుట్స్ ఓన్లీ, హెన్స్ ద సిస్టమ్ ఈస్ క్యాజువల్. నెక్స్ట్ టైం వేరియంట్. ఇది టైం వేరియంటే కదా, ఎందుకంటే
Yes, sir.
కోఎఫిషియంట్స్
It has variable.
నెంబర్స్ ఉండదు. ఇక్కడ 1, ఇక్కడ 2y ఉంది, y అంటే వేరియబుల్ కదా.
Yes, sir.
నెక్స్ట్ 3t, ఇక్కడ t కూడా వేరియబులే కాబట్టి 2 వేరియబుల్స్ ఉన్నాయి కాబట్టి హెన్స్ ఇట్ ఈస్ టైం వేరియంట్. ఓకే,
త్రిదేవానంద్. సార్ త్రిదేవానంద్, అది ఇందాక డౌట్ అడిగాడు కదా సార్, అది
ఏంటంట
అర్థమైంది లేదో అడిగి.
ఓకే, నౌ మోడల్ 3 is completed. ఫస్ట్ యూనిట్ లో ఇంపార్టెంట్ ప్రాబ్లమ్స్ అయిపోయాయి, ఇంకా ఇంపార్టెంట్ ప్రాబ్లమ్స్ ఉన్నాయి. ఇవి మోస్ట్ ఇంపార్టెంట్ ప్రాబ్లమ్స్. ఈ నెక్స్ట్ ఇంపార్టెంట్ ప్రాబ్లమ్స్ ఉన్నాయి, అవి చూద్దాం. అదేంటంటే పీరియాడిక్, ఎపీరియాడిక్, క్యాజువల్, నాన్ క్యాజువల్. మరి అదేంటి సార్ ఇప్పుడే కదా సార్ చెప్పుకున్నాం అంటే, ఇప్పుడు చెప్పుకున్నాం ఎందులోని, సిస్టమ్స్ లో చెప్పుకున్నాం, ఇప్పుడు సిగ్నల్స్ లో చెప్పుకుంటాం. ఓకే, ఇదేంటిది, పీరియాడిక్, ఎపీరియాడిక్. ఆల్రెడీ మీకు మిడ్ ఎగ్జామ్స్ లో ఇచ్చాను ఈ క్వశ్చన్, అందరూ కూడా
Yes, sir.
దీనికి మెథడ్ 1 రాస్తారు. ఓకే, సింగిల్ సిగ్నల్ ఉంటే మెథడ్ 1, 2 సిగ్నల్స్ ఉంటే మెథడ్ 2. ఓకే, మెథడ్ 1 ఏంటి చూడండి, ఇక్కడ మెథడ్ 1 హియర్ గివెన్ క్వశ్చన్ ఈస్ sin 2 pi t ఈజ్ ఈక్వల్ టు x of t. ఎప్పుడు కూడా సిగ్నల్ మనం దేని రిప్రజెంట్ చేస్తాం, x of t. x of t అంటే దేని రిప్రజెంట్ చేస్తుంది, ఇన్పుట్ సిగ్నల్. ఓకే, నెక్స్ట్ ఇది స్టాండర్డ్ ఏంటి, a sin omega t. సో కంపేర్ విత్ a sin omega t. నౌ వాట్ ఈస్ omega వాల్యూ, 2 pi, a వాల్యూ 1. when you got always omega or t, okay, if you know t value, find omega. If you know omega value, find t value. Okay, that is very, very important in single step. Okay, so so here we find omega value 2 pi. Next step is to find t value. What is the t value, 2 pi by omega. Okay, so 2 pi by omega, 2 pi by 2 pi, so t value is 1. Okay, next here what is the condition for periodic? For periodic, x of t, okay, should be equal to x of t plus capital T. Okay, this is the condition for periodic. So here this is the x of t, already we know this is the x of t. Okay, now we write the condition x of t is equal to x of t plus t. Now we have to go for x of t plus capital T. X of t plus capital T. That means in place of t, we have to put t plus capital T. T plus capital T. Okay. Now multiply 2 pi t plus 2 pi capital T. What is the value of capital T? Already we know. What is the value? 1. Substitute that value. Okay. Now substitute the value 2 pi. Okay. Generally 2 pi plus theta is 2 pi plus theta is this value only. Already we know. But every time you have to apply this formula. What is the formula? Sin A plus B. Okay. This term is A. This term is B. So sin A plus B is equal to sin A cos B plus cos A sin B. Okay. Now what is sin A? Sin 2 pi t. 2 pi t cos 2 pi. Cos 2 pi. Cos 2 pi value 0. Next cos A. Cos A means cos 2 pi. Cos 2 pi t. Sin B. Sin B means sin 2 pi. Sin 2 pi value 0. Okay. Here cos 2 pi value is 1. Okay. Not 0. Cos 2 pi value 1. Sin 2 pi value is 0. Next 1 into this value and 0 into this value 0. Now what is the value? Sin 2 pi t. What is the given question? Sin 2 pi t. Both are equal, no? So this condition is valid. Okay. Whenever this condition is valid, it is called a periodic.
Periodic.
Okay. This is the procedure to find periodic and aperiodic. Okay. Next e power j theta. For e power j 4 pi t, compare with e power j omega t. Now what is the omega value? 4 pi. Whenever we find omega value, find t value. T is equal to 2 pi by omega is equal to 2 pi by 4 pi is equal to 1 by 2. Okay. Next, this is x of t. Next, what is the condition? X of t should be equal to x of t plus t. So now we have to find x of t plus t. In place of t, put t plus capital T. Okay. Now e power 4 pi t, e power 4 pi t plus e power j 4 pi capital T. This is multiplication. This is plus. It is divided. It can be converted into multiplication. That is e power j 4 pi t into e power j 4 pi capital T. Already we know what is the capital T value. Okay. What is the capital T value?
1 by 2.
1 by 2. 2 get cancelled. Here 2 pi. E power j 2 pi. Already we know what is the formula of e power j theta. E power j theta formula is cos theta plus j sin theta. This formula is very, very important. Okay. In place of theta, what is the value? 2 pi. So cos 2 pi plus j sin 2 pi. Already we know sin cos 2 pi. In the problem cheppuno. Cos 2 pi value 1, sin 2 pi value 0. Now what is the value? 1. So this value is 1. Okay. Now e power j 4 pi t. E power j 4 pi t is x of t. It's in question kada.
Yes, sir.
So now this condition is valid. X of t is equal to x of t plus capital T is valid. Okay. Hence it is periodic.
Periodic.
Okay. మీ ఎగ్జామ్ లో మాక్సిమం ఫస్ట్ క్వశ్చన్ పీరియాడిక్ అపీరియాడిక్ అని క్వశ్చన్ ఇస్తాడు. అది తప్పితే మోడల్ 1, మోడల్ 2, మోడల్ 3 అవి కూడా తప్పితే క్యాజువల్ ఇవి ఉన్నాయి కదా, క్యాజువల్ నాన్ క్యాజువల్ అది అడుగుతాడు. ఈ నాలుగిట్లో ఖచ్చితంగా ఒక క్వశ్చన్ వస్తుంది. ఓకే. నెక్స్ట్ 2 సిగ్నల్స్ ఇచ్చినప్పుడు, ఓకే, వెన్ ఎవర్ 2 signals are given, now we have to find periodic aperiodic. Okay. x1 దీన్ని దేంతో కంపేర్ చేస్తున్నాం? cos omega 1t. దీన్ని దేంతో కంపేర్ చేస్తున్నాం? sin omega 2 t2. omega 2 t2. Now on comparison, omega 1 is equal to 2. Omega 1 is equal to 2. Omega 2 is equal to √3. Now when you got omega 1, we have to find t1. So t1 is equal to 2 pi by omega 1, that is equal to 2 pi by 2, that is equal to pi. So t1 value is pi. When you got omega 2, we have to find t2. So t2 is equal to 2 pi by omega 2, 2 pi by √3. Okay. Now we have to find a ratio. Ye find chestam? Ratio find chestam. Now ratio t1 by t2 is pi by 2 pi by √3. Now what is the value? √3 by 2. Okay. Here condition is ratio should be in the form of P by Q.
P by Q.
And P comma Q should be belongs to integers.
Rational.
Okay. So P by Q should be rational. Okay. Mari root 3 అనేది ఏంటి? Irrational number.
Irrational.
Okay. Root 3 is a irrational number. Hence it is not rational.
Periodic.
So it is called a periodic. Okay. Next ఇది చూద్దాం. ఇక్కడ omega 1 200 pi. ఇక్కడ T1 value is 1 by 100. Omega 2 is 100. T2 is 2 pi by 100. Now we have to calculate ratio. Okay. We have to calculate ratio. T1 by T2 is equal to ఎంత వచ్చిన value 1 by 2 pi. Pi is a irrational number. So pi is a irrational number, but we want a rational. So it is irrational number. Hence it is called not periodic or aperiodic.
Yes, sir.
Okay. మరి ఒకవేళ పీరియాడిక్ అయింది అనుకోండి. Okay, if it is periodic, then how can you find capital T value? You have T1 value and T2 value. Now how can you find T value? T value can be find LCM of T1 and T2. Okay, LCM of T1 and T2. రెండింటికి LCM క్యాలిక్యులేట్ చేస్తాం, ఏది వస్తే వాల్యూ T వాల్యూ అవుతుంది. ఓకే. నెక్స్ట్ ఇప్పుడు దాకా ఏం చేసాం ప్రాబ్లం? ప్రీవియస్ ప్రాబ్లమ్ ఈస్ బిలాంగ్స్ టు కంటిన్యూస్ ఓన్లీ. నౌ ద ప్రాబ్లమ్ బిలాంగ్స్ టు డిస్క్రీట్. ఓకే. ఆల్రెడీ మీకు వాట్సాప్ గ్రూప్ లో పెట్టాం కదా. ఆల్రెడీ ఐ టోల్డ్ దట్ ఎవ్రీ టాపిక్ షుడ్ బి ప్రిపేర్డ్. One is continuous and second one is discrete. Then only the topic is completed. Okay. In exam, he will ask about periodic or discrete. Sorry, periodic and continuous. Okay. In exam, he will ask about continuous or discrete. So up to now, we prepared for a continuous. Now it is a discrete. Okay. Same concept. What is the concept? Periodic or aperiodic? Okay. Now same. In continuous, it is T. In discrete, it is N. Okay. In T is for a continuous. N is for a discrete. Okay. Now we are at a discrete. So it is N value. Now compare with the A sin omega N. Okay. If it is continuous, then it is called omega T. But here it is discrete. So sin omega N. Compare both. Omega value is 0.02 pi. Okay. Previously we find whenever we got omega, we find capital T previously. Now what we have to find? We have to find F. F means frequency. Okay. So we have to find frequency. So 2 pi F is equal to omega. What is the omega value? 0.02 pi. Okay. So 2 pi get cancelled. Frequency 0.01. This should be right. This should be written in the form of K by N. అక్కడ ఏమని చెప్పాం? P by Q. Okay. There ratio is P by Q. Here ratio is K by N. Okay. Now what is the ratio? 1 by 100. In this, what is the value of K? 1. What is the value of N? 100. This N value is called a fundamental period. ఇదే మనకు కావాల్సిన వాల్యూ. ఓకే. అక్కడ క్యాపిటల్ టీ వాల్యూ కావాలంటే ఏం చేసాం? You have to find LCM of T1 and T2. Here we have to we can find the value N value as a fundamental period. Okay. Now see here, 1 is a integer, 100 is a integer. So it is a rational number. Rational number, it is periodic. Okay. Next, sin 5n. Sin 5n. So omega is equal to 5 pi. 2 pi F is equal to 5 pi. F is equal to 5 by 2. So K value is 5. N value is 2. It is rational. Okay. See here, 5 is a integer and 2 is a integer. So ratio is rational. So it is periodic. Okay. ఇక్కడ చూడండి. F value how much? 2 by pi. Okay. 2 by pi. Here 2 is a integer and pi is a irrational number. Okay, pi is a irrational number. So these two cannot be integers. Hence it is a irrational number. Irrational number means it is aperiodic. Okay. Here F1. Now up to here, single signal is given. Now we have two signals. Okay. Now we have two signals. Two signals. Omega 1 is calculated. Omega 2 is calculated. F1 is calculated. F2 is calculated. F1 value 1 by 3. F2 value 1 by 5. Here also we have to find ratio. Okay. అక్కడ కూడా ratio calculate చేసాం కదా T1 by T2. Here also we have to calculate ratio F1 by F2. Okay. Here ratio 5 by 3. Okay. K value is 5. N value is 3. K and K is equal to 5. N is equal to 3. These 5 comma 3 are integers. Okay. 5 comma 3 belongs to integers. Hence 5 by 3 is a rational number. So it is a periodic. Okay. Now what is the value of F? What is the value of F? Fundamental period.
LCM of F1 and F2.
LCM of both.
F1.
Okay. So casual. Casual means whenever waveform is on a t greater than 0, then it is called casual. If the waveform is on left side, then it is called anti-casual. Okay. When the waveform on both sides of 0, okay, both sides of 0, left side and right side, then it is called non-casual. See here, right side is called casual, left side is called anti-casual, non-casual means both sides. Okay. ఇక్కడ ఒక ఇంపార్టెంట్ పాయింట్ ఏంటంటే ఆల్వేస్ x of t less than 0. Okay, always you have to take x of t less than 0. If it is not less than 0, then it is casual. X of t less than 0, then it is anti-casual. Okay. ఇక్కడ మీరు అబ్జర్వ్ చేయండి, ఇక్కడ ఏం రాశారు? X of t is equal to 0, t less than 0. Okay. That means this is the t less than 0. Okay. This portion is t less than 0. T less than 0 value is 0. Okay. X of t is equal to 0. So it is casual. Here x of t is equal to 0 for t greater than 0. That means this portion. T greater than 0. T greater than 0 is 0. Hence it is anti-casual. Okay. మీరు రాసినట్టు ఎలా రాయాలి అంటే రివర్స్ లో రాసినట్టు రాయాలి. ఓకే, గుర్తుపెట్టుకోండి, ఇది చాలా ఇంపార్టెంట్ పాయింట్. ఇలా రాస్తేనే మార్కులు వేస్తారు. ఓకే. ఫర్ క్యాజువల్ వీ హ్యావ్ right side waveform. So left side is t less than 0. T less than 0, x of t is 0. For anti-casual, left side we have waveform. Right side, that is t greater than 0, no waveform. X of t is equal to 0. Okay. These are the important topics. That is a casual, anti-casual, non-casual. One important topic. Another important topic is periodic, aperiodic. Okay. Periodic and aperiodic లో continuous చూసాం. Next discrete చూసాం. Okay. Now model 3 is completed, and in unit 1 two important topics also completed. Okay. Next model 4. Model 4 belongs to unit 2. Okay. Model 4 belongs to unit 2.
సార్
చెప్పండి.
క్యాజువల్ యాంటీ క్యాజువల్ ఒకసారి సమ్ చెప్పండి సార్.
ప్రాబ్లం చెప్పాను కదా.
ఒకసారి మళ్ళీ చెప్పండి.
ఓకే. ప్రాబ్లం చెప్పలేదా? ఓకే, ప్రాబ్లం చెప్పలేదు. ఓకే
సార్ అందుకే అడిగాను.
ఓకే ఓకే, థ్యాంక్ యూ. ఇక్కడ చూడండి, now see here. Here two signals are there, e power 2t, u of t minus 1. Okay, u of t minus 1 means t is equal to 1. Okay, t is equal to 1. Okay, plus t ఉంది కాబట్టి right side. Okay, this is the waveform. And u of 2t, this is u of 2t. Put t is equal to 0. What is the value? E power 0. E power 0 means 1. So at 0 value 1. Next calculator, in calculator take the value of 2. E power 4. E power 4. Next e power, it is gradually increasing. So this waveform on right side of the right side. Okay, this waveform is right side, and this waveform also right side. Both waveforms are right side, so resultant waveform should be right side. Okay, both signals are right side. Okay, if both signals are right side, what is the value called?
Casual.
Casual. Okay, next here e power minus 3. E power minus 3 means this is the waveform. Okay, in calculator, in exam, in calculator, okay, take the value t is equal to 0, t is equal to 1, t is equal to 2. Okay, we will find the value. Okay, from 1 gradually value is decreasing, so value is gradually decreasing. Next, u of minus t plus 2. So minus t plus 2, t is equal to 2. So the value is starts from 2. Okay, 2. Here minus t means left side. Okay, left side. Minus t means left side. So it is the waveform going in a left side. Okay, here we have t greater than 0, we have value. T less than 0, we have value. Here we have only value at t greater than 0. Okay, on mixing these two, we have two values. Okay, on multiplying these two, we have both values. Okay, అది తక్కువ ఎక్కువ మొత్తానికి ఈ రెండు కూడా రెండు సైడ్లు వాల్యూస్ ఉన్నాయి. రెండు సైడ్లు వాల్యూస్ అంటే ఏమంటాం? If you have both sides values, then it is called non-casual. Okay, next here sine sync 2 theta. Already we know what is the waveform of sync. Okay, sync means at 0 it has maximum value, that is 1, and gradually decreases. This is called a sync function. Okay, sync function is equal to sine theta by theta. Okay, now what is the value? 3 sync 2 theta. Okay, 3 sync 2 theta. Here quotient is 3, so the value is 3. Next 2t. Okay, here 1, 2, 3, that line. Here also gradually decreasing. Okay, here value kept aside, but the waveform is on left side and right side. So we have signals on both sides, then it is called non-casual. Okay, here also u of t plus 2. U of t plus 2 is on both sides. U of t minus 2. U of t minus 2 on right side. Whenever these two signals are mixed, this is the resultant signal. Okay, this signal is in both sides, that is left side and right side. So it is called non-casual. ఈ వేవ్ ఫార్మ్స్ ఎలా గీస్తామో మనకు తెలుసు ఆల్రెడీ మనం బేసిక్స్ చెప్పుకున్నాం. ఓకే, ఎలాగా? హియర్ t plus 2. Here t plus 2. T plus 2 is equal to 0. T is equal to minus 2. So value starts from, waveform starts from minus 2. Okay, minus 2. So gradually upward direction. Here we have plus t. Plus t means right side. Okay, next minus u of t minus 2. T minus t is equal to 0. T is equal to 2. So at 2 value started. Okay, value started. Minus means minus 1. So here downwards -1. Okay, we are at here. Now it is plus t. Plus t means right side. Okay, right side. So this is up to infinity. This is up to infinity. At 2, okay, this is value. This height is 1. Here this height is also 1. This is positive 1. This is negative 1. So this positive signal and negative signal get cutted. Okay, this signal will be cancelled from 2. Okay, ఎక్కడైతే వాల్యూ 2 ఉందో ఆ వాల్యూ 2 నుండి పాజిటివ్ సిగ్నల్ అండ్ నెగిటివ్ సిగ్నల్ is cancelled. Okay, so signal is from 2 to -2 to signal is from -2 to 2. Okay, signal is from -2 to 2. So this signal is in both sides, so it is called a non-casual. Okay, got it?
Yes, sir.
Next. Okay, next in discrete also. See here, in discrete also same concept. Okay, u of n plus 4. N plus 4 is equal to 0, n is equal to -4. So it starts from -4. Okay, height is 1. So waveform starts from here. Okay, but in discrete we take only spikes, that is impulse signals. Okay, each line is called impulse signal. These impulse signals are written from -4 to infinity. Here -1. Okay, start from -1. N minus 2 is equal to 0, n minus 2 is equal to 0, n is equal to 2. From 2 -1 up to infinity. So this is positive signal, this is negative signal. Positive signal, negative signal get cancelled from 2. ఓకే, ఎక్కడైతే 2 ఉందో ఆ 2 దగ్గర నుంచి పాజిటివ్ సిగ్నల్ నెగిటివ్ సిగ్నల్ గెట్ క్యాన్సిల్డ్ అండ్ వేవ్ ఫార్మ్ ఫ్రమ్ -4 to 2. Here also we have signals on both sides, so it is called non-casual. ఓకే, ఇప్పుడు క్వశ్చన్ అడుగుతాను చెప్పండి. దిస్ ఈజ్ క్యాజువల్, నాన్ క్యాజువల్. ఓకే, దిస్ ఈజ్ బిలాంగ్స్ టు సిగ్నల్. నౌ ఇన్ సిస్టమ్ హౌ వీ కెన్ ఫైండ్ క్యాజువల్ అండ్ నాన్ క్యాజువల్ ఇన్ సిస్టమ్? In system, how we can find casual, non-casual? Y of t, y of t minus 1, y of t plus 1. Y of t is present, y of t minus 1 is past. When these two are there, then it is called casual. When we have y of t plus 1, that is future value. If we have at least one future value, then it is called non-casual. Okay, this is the concept for a system, but this is the concept for a signal. Okay, if signal is lies on both sides, then it is called non-casual. The signal is lies on right side, then it is called casual. Okay, next model 3. Okay, model 3 completed. Model 4. Here model 4 belongs to unit 2, that is convolution. Okay, already we know this convolution concept is present in each and every unit. Unit 2, unit 3, unit 4, unit 5. Okay, in each and every it is present, but maximum chances are in unit 2 and unit 4. Okay, unit 2 and unit 4, these are the maximum chances for convolution property. Okay, this is model 3. Model 4 is example 1. Okay, ఇది ఏంటంటే this is model 3. This is model 3 discrete. Model 3 discrete system or discrete signals. ఇందాక చెప్పుకున్నది ఏంటి, క్యాజువల్ నాన్ క్యాజువల్, అది సిగ్నల్స్ లో. ఓకే, నెక్స్ట్ టైం వేరియంట్. ఓకే, నాన్ లీనియర్, డైనమిక్ అండ్ ఇండైనమిక్, డైనమిక్ ఆర్ స్టాటిక్. ఓకే, క్యాజువల్, నాన్ క్యాజువల్, దీస్ ఆర్ బిలాంగ్స్ టు model 3 but continuous. Model 3 continuous, but here model 3 discrete system. Okay, discrete system or signal. Okay, main is signal, that is a system, discrete system. Okay, here discrete system is given. For the discrete system we have to find whether it is linear, non-linear, or linear, non-linear. See here, linear, non-linear, casual, time invariant, and stable. You have to find these concepts. Okay, ఈ కాన్సెప్ట్ అర్థమైందా? This is also model 4. This is model 3. This is model 3 discrete system. Okay, previously we discussed about the model 3 continuous. Okay, so మధ్యలో ప్రాబ్లం చెప్పుకున్నాం, అదేంటి, that is just important question. Okay, that is just important question. But before that we discussed about a model 3 continuous. Okay, that is non-linear, dynamic, time invariant, that like. Okay, now model 3 discrete signal. Now this is the question. In this question we have to find a linear, casual, time invariant, or stable. Okay, these 4 parameters you have to check. Now for linear, what is the condition for linear? The condition for linear is the weighted sum should be linear, that is no square, cube, or involved. Okay, so this equation is y1 and same equation is y2, y1 y2, y1 y2, y1 y2, x1 x2, x1 x2. Okay, so this is a y1 plus b y2. Next, a y1 plus b y2, a x1 plus b x2, a x1 b x2. So all are linear. Superposition theorem is applied. Okay, hence the system is linear. Okay, the system is linear. Next, whenever these conditions are applied, this is also called stable. Okay, these conditions are applied, these are called stable. Okay, next, for casual. Next is for casual. Already we discussed about this one. N minus 1 means past, n means present, n plus 1 is future. Okay, so for casual we have, what are the terms we have? Y of n, that is present, y of n minus 1 past, x of n present, x of n minus 2 past. So overall we have only present and past. When we have present and past, then it is called casual. Okay, so it is casual. Next, time invariant. Time invariant means all constants should be numbers only. Okay, so here we have all constants are numbers only, so time invariant. Okay, this is very very important. ఇక్కడ మిస్టేక్ రాసినట్టున్నాను చూడండి. హియర్ స్టేబుల్ అని రాశాను కదా, ఇది స్టేబుల్ కాదు. ఫస్ట్ కాన్సెప్ట్ దేని గురించి? ఫస్ట్ కాన్సెప్ట్ అబౌట్ లీనియర్. సో వీ హ్యావ్ టు రైట్ హియర్ లీనియర్. ఓకే, మిస్టేక్ రాసిన ఇక్కడ లీనియర్. నెక్స్ట్, హియర్ Now this concept is very, very important. It's చాలా important. చాలా జాగ్రత్తగా చూడండి. Okay, this concept is applicable any number of times. That means number of situations in number of units, this concept is applied. Okay, for stable, the condition is sigma n is equal to minus infinity infinity. These values should be less than infinity. Okay, what is the condition? Minus infinity in sum of minus infinity infinity modulus. Modulus means we have only positive value. Okay, so now tell what is the value? Sum of minus infinity infinity h of n value should be less than infinity. Okay, if this value is less than infinity, this is stable. If this value is equal to infinity, then it is not stable or unstable. Okay, now what is the condition? H of n. That means in place of y of n, you have to put h of n. Okay, next in place of x of n, you have to place delta of n. Here delta of n means impulse. Okay, whenever impulse signal is given, then h of n. Here also this is also a signal h of n. అంటే ఎప్పుడైతే మీరు ఇన్పుట్ డెల్టా ఆఫ్ ఎన్ ఇచ్చారో అవుట్పుట్ ఏమొస్తుంది? h of n వస్తుంది. Whenever x of n input is given, y of n is obtained. That like here delta of n is obtained, then delta of n is given, h of n is obtained. Okay, now from according to the equation, here y of n is there. In place of y of n, you place h of n minus here y of n minus 1. Here we have y of n minus 1. In place of y of n minus 1, h of n minus 1. Here x of n. In place of x of n, put a delta of n. Plus here x of n minus 2. X of n minus 2. That means x of n minus 2 means delta of n minus 2. Okay, step advaina. Whenever the given question, in this given question, we place x of n is equal to delta of n, y of n is equal to h of n. Okay, ఇక్కడ n minus 1 ఉంటే n minus 1, n minus 2 ఉంటే n minus 2. Next, now we calculate 0. Okay, put n is equal to 0. So h of 0 is equal to minus of 0 minus 1, 0, 0 minus 2, minus 2. Okay, now what is the present value? ఇక్కడ చూడండి, జాగ్రత్తగా అబ్జర్వ్ చేయండి. Here present value is n is equal to 0. So when n is equal to 0 only, this value is 1. Okay, impulse value enta value 1. Okay, always impulse value is 1. So whenever n is equal to 0, here n is equal to 0 is the present value. So for a present value only, the value is 1. Okay, so for this value is 1. This is past value 0. This is past value 0. So here value is 0 plus minus 1 minus 0 plus 1 plus 0. So 1. Okay, next put n is equal to 1. So here n is equal to 1 is the present value. Okay, n is equal to 1 is the present value. Now n is equal to 1. 1 minus 1, 0. Okay, n minus 1, 0. Delta of here 1. Delta of 1. Next delta of n minus 1. Now what is the value? H of 0. Okay, h of 0 is 1. ఎక్కడైతే మనకి 0 అని వస్తుందో అక్కడ మాత్రమే వాల్యూస్ ఉంటాయి. ఓకే, నెక్స్ట్ సరే ఇక్కడ చూడండి, h of 0 value is how much value? 1. Okay, automatically we have h of 0 is equal to 1. Put this value here. H of 0 is equal to how much value? 1. Put this value here, minus 1 plus there is no delta of 0. Okay, delta of 0, there is no delta of 0. So this is 0, this is 0. Minus 1, 0, 0, minus 1. So h of 1. What is h of 1 value? h of 1 value anta? Minus 1. Minus of minus 1, 1. Okay, here delta of 2. Delta of 2, we should get only delta of 0 only. Okay. So delta of 2 value 0, delta of 0. So delta of 0 value is 1. Okay. So 1 0 1 1 0 1 2. Next h of 3 minus 2. So here h of 2 is equal to 2. Put this value here minus 2. Minus 2 plus delta of 3 0. Delta of 1 0. Minus 2 plus 0 0, that is minus 2. So whenever we are progressing to infinity, these values are 1. Okay. 1 plus 1 plus 2 plus 3, that like it will be infinity. So that is the impulse response is not absolutely summable. Okay. This point chala important గుర్తుపెట్టుకోండి. Not absolutely summable. Question అడుగుతాడు whether these function is absolutely summable అని అడుగుతాడు. ఓకే. అంటే ఈ ప్రాసెస్ చేసిన తర్వాత ఇన్ఫినిటీ వాల్యూ వస్తే అప్పుడు ఏం రాస్తారు? నాట్ అబ్సల్యూట్లీ summable. Okay. The system is unstable. Therefore the given question is non-linear. First condition. Next casual, time invariant and unstable. Okay. First condition linear kada. Linear, casual, time invariant and unstable. Okay. ఈ పాయింట్ అర్థమైందా? ఫర్ స్టేబుల్.
సార్ ఇంకోసారి చెప్పండి సార్.
ఓకే. ఇప్పుడు చూడండి, వాట్ ఈస్ ది గివెన్ క్వశ్చన్ హియర్? y of n minus 1 here, y of n is equal to minus y of n minus 1 plus x of n plus x of n minus 2. Okay, this is the given question. Okay, next in this question now we are placing x of n is equal to delta of n. Delta of n is the input, that is impulse function. Okay, input impulse function ఇచ్చినప్పుడు దానికి అవుట్పుట్ ఏమొస్తుంది? h of n. Okay, x of n is input, y of n is the output. Here delta of n is the input, h of n is the output. Okay, now in place of y of n you have to write h of n. So h of n minus next y of n minus 1. So h of n minus 1 plus x of n. X of n and delta of n plus x of n minus 2. Okay, here x of n minus 2 means x of means delta. So delta of n minus 2. Okay, ఈ పాయింట్ అర్థమైందా?
ఎస్ సార్.
Okay, next what is the condition for stable? These condition, that is sigma n is equal to minus infinity to infinity, modulus of h of n value is less than infinity. Okay, if this value is less than infinity, then value is stable. Okay, if it is equal to infinity, it is unstable. That is the condition. Okay, so for that one we are calculating each and every value, that is h of 0, h of 1, h of 2, h of 3, because n value varies from 0 to infinity. Okay, 0 to infinity. In this equation we are taking n is equal to 0. So n is equal to 0. Here 0 minus 1 minus 1. Okay, here n is equal to 0. Here 0 minus 2 minus 2. Okay, here delta of n means impulse function. Already we know for impulse function is equal to 1. Okay, for impulse function is equal to 1, delta of t is equal to 1 at t is equal to 0. Okay, delta of t is equal to 0 for t not equal to 0, is equal to 1 at t is equal to 0. Okay, so delta of t is equal to 1. ఎక్కడది? t is equal to 0. So delta of 0 is equal to 1 అవుతుందా?
ఎస్ సార్.
Okay, సో ఎక్కడైతే 0 వస్తుందో అక్కడ మాత్రమే 1 రాస్తుంది. మిగతా ఏదైనా సరే వాల్యూ 0. ఓకే, నెక్స్ట్ నౌ హియర్ h ఆఫ్ -1. ఇక్కడ చాలా జాగ్రత్తగా అబ్జర్వ్ చేయండి. డెల్టా ఆఫ్ 0 మాత్రమే 1, డెల్టా ఆఫ్ -2, డెల్టా ఆఫ్ -1 ఈ వాల్యూస్ ఎప్పుడు కూడా 0. ఓకే, ఇక్కడ h ఆఫ్ -1, h ఆఫ్ 0 అనేది ప్రీవియస్ వాల్యూస్ మీద డిపెండ్ అవుతాయి. ఓకే, సరే ఫస్ట్ వాల్యూ చూద్దాం. h ఆఫ్ 0, నెక్స్ట్ మైనస్ h ఆఫ్ -1. మనకి ప్రీవియస్ గా h ఆఫ్ -1 వాల్యూ ఏమైనా ఉందా? లేదు.
లేదు సార్.
కాబట్టి ఇది 0. డెల్టా ఆఫ్ 0 వాల్యూ ఇక్కడ ఉంది కదా. ఓకే,
Yes,
డెల్టా
sir.
ఆఫ్ 0 ఈస్ 1. సో ఇక్కడ వాల్యూ 1. డెల్టా ఆఫ్ -2, ఇక్కడ 0 తప్పించి డెల్టాలో ఏ వాల్యూ వేసినా 0. సో డెల్టా ఆఫ్ -2 ఈస్ 0. టోటల్ గా ఏమైంది? 0 ప్లస్ 1 ప్లస్ 0 ఎంత? 1. ఇప్పుడు మనకు కొత్త వాల్యూ వచ్చింది. ఏంటది? h ఆఫ్ 0 ఈజ్ ఈక్వల్ టు 1. ఓకే, అంటే నెక్స్ట్ స్టెప్ లో h ఆఫ్ 0 అనేది ఎక్కడన్నా ఉంటే, ఓకే, ఈ నెక్స్ట్
Sir.
స్టెప్ వెన్ ఎవర్ యూ హ్యావ్ h ఆఫ్ 0,
English, please.
ఇంగ్లీష్. ఓకే, మర్చిపోతున్నాను. ఓకే, వెన్ ఎవర్ హియర్ h ఆఫ్ n ఈజ్ ఈక్వల్ టు minus h of from this equation, whenever it is y, put h. Okay, y of n, h of n, y of n minus 1, h of n minus 1. X means delta of n. Sorry. Next, delta means in place of delta, in place of x we have to put sorry, delta of n. Here x of n minus 2. Sorry. Here in place of x you have to put delta of n minus 2. Got this pointer? Whatever may be the h of n value, okay, in place of y of n you have to put h of n. In place of x of n you have to put delta of n. Okay, now this is the given equation. In this given equation, y of n means how much you have to put h of n. In place of y, h. Okay, so h of n, y means h minus h of n minus 1, minus h of n minus 1. Next, x of n. In place of x of n, what you have to put? Delta of n. Next, x of n minus 2. So delta of n minus 2. Okay, got it? This step.
Yes, sir.
Okay. Now, already we know delta of t is equal to 1. This is impulse function. For impulse function, delta of t is equal to 1 at t is equal to 0. So delta of 0 is equal to 1. Okay, for any value it is 0. That is delta of 1 0, delta of 2 0, delta of minus 1 0, delta of minus 2 0. That is at delta of 0 only the value is 1. Okay, for any value,
Yes, sir.
delta of minus 1, delta of minus 2, delta of minus 3, delta of plus 1, delta of plus 2, any value is 0. Okay,
Yes, sir. Yes, sir.
now h of minus 1. Previously we have any value of h of minus 1? Previously no value, so this value is 0. Next, plus delta of 0. Now delta of 0 is equal to 1. We know, put this value 1.
Yes, sir.
Okay, 0 plus 1 plus delta of minus 2. Already we discussed any value
0.
of delta, it is 0 except for 0. Okay, so
Yes, sir.
1 plus 0. So 0 1 0, value is 1. Now we got the new value. What is the new value? H of 0 is equal to 1.
1. Yes, sir.
Okay, in next step, if any value is h of 0, we can put value as a 1.
Yes, sir.
Okay, now put n is equal to 1. N is equal to 1. What is this equation? Minus h of 1 minus 1 0. Here 1. Here 1 minus 2 minus 1.
Yes, sir.
Okay.
Yes,
So
sir.
h of 0, we have any value of h of 0? Yes, h of 0 is equal to 1. So
Yes, sir.
minus 1
Yes, sir.
plus here delta of 1.
0.
Whenever delta of 0 only, we have 1. Okay. Delta of
Yes, sir.
0 only, we have the value 1. So for delta of 1, it is 0. Delta
0.
of minus 1, 0.
0.
So minus 1, 0, 0, minus 1.
Yes, sir.
Okay. ఏమైనా మెథడ్ ఫాలో అవుతున్నారా?
Yes, sir.
Yes, sir.
Okay. Next, put n is equal to 2. N is equal to 2. Now 2 minus 1, 1, 2, 2, 2 minus 2, 0. H of 1.
1.
Already in previously h of 1 is 1.
Minus 1.
So here minus of minus 1 plus 1. Delta of 2, 0. Delta of 0, 1.
1.
So 1, 0, 1. That is 2. Now what is the value? H of 2 is 2.
2. Yes, sir.
Next, put n is equal to 3. Put n is equal to 3. Put n is equal to 3. Here 3 minus 1, 2. Here delta of 3. 3 minus 1, 1. Now h of 2. What is the value of h of 2? Already we have h of 2 value 2.
2.
That is minus 2. Minus 2 plus delta of 0. Delta of 0 is equal to 1. Other than that, value is 0. So delta of 3 is 0. Delta of 1 is 0. Okay. So
Yes,
minus
sir.
2, 0, 0. Minus 2, 0, 0. Minus 2. Now up to infinity, we have to do like this. Okay. So what is the condition here? The condition is modulus of h of n infinity from minus infinity to infinity. These values sum should be less than infinity. Okay. Now what is the first value? 1. What is the next value? Minus 1. But we have to put in a modulus. When you have to put in modulus, when we put in modulus, we get only positive value only. So minus 1 becomes a plus 1. Next 2. Okay, next minus 2. Minus 2 becomes a plus 2. What is the next value? 3. Next
3.
minus 3 becomes a plus 3. Next value 4. Next minus 4. Minus 4 becomes a plus 4. That is, this series goes on and this value becomes infinity. Because no negative terms, okay, always positive terms. Positive becomes a sum. This sum is almost equal to infinity. So it is not less than infinity. Hence, this is not absolutely summable. This point is very, very important. Okay. Impulse response is not absolutely summable. Okay. He may ask question. Okay. Whenever he given this equation and he said that whether this equation is summable or not, that like, then you have to do this process. Okay. So you have to do this process and impulse response is not summable. Why? Because it is equal to infinity.
Infinite.
Okay. So response is not absolutely summable. The system is unstable. Okay.
Yes, sir.
This is
Yes,
the
sir.
important concept. Okay. This is the important concept in discrete. Okay. Now see here, for continuous, the equation is, for continuous equation, see here, continuous equation, d cube y of dt by dt cube plus 2 d square y of t by dt square plus 4 dy of t by dt is equal to x of t. This is continuous equation. Okay. For discrete equation, previous equation, what is the previous equation? Y of n is equal to minus y of n minus 1 plus
Yes,
x
sir.
of n plus x of n minus 2. Okay. Now the important point is, these continuous equation is called differential equation. Very, very important. Okay. In each and every chapter, this concept will be there. Okay. What is the concept? Differential equation. Okay. Whenever differential equation came, automatically it is called continuous signal or continuous system. Whenever these equations, these equations, see here, these equation is called difference equation. What is this equation called? Difference equation. Whenever difference equation is mentioned, automatically it goes to discrete signal or discrete system. This is very, very important. Okay. This is the model number 5. This is model number 5. This is model number 6. Okay. Got it? Whenever you
Yes,
got
sir.
a differential equation, this comes under continuous system. Whenever y of n minus 1, x of n came, this comes under difference equation. Okay. This concept is present in each and every unit. Okay. So tomorrow evening we discuss about this model number 5, 6, 7. Okay.
Okay, sir.
Up to now, okay. Up to now we will discuss about model number 5. Today class is up to model number 5 only. Tomorrow 5 models. Okay. Now we are at a model 4. Okay. Now we are at a model 4. Model 3 is completed. Now we are at model 4. What is the model 4? Convolution. Okay. Convolution. See, this is the model 4 convolution. This convolution present in unit 2, unit 3, unit 4, unit 5. Okay. So I will discuss about the basic convolution problem. Okay. Basic convolution problem. So what is the formula for convolution? Already we know what is the formula for convolution. See here, convolution means mixing of two signals. Okay, what is the convolution? Convolution means mixing of two signals. Okay, so x1 convolution x2 is equal to minus infinity infinity x1 of, this is called a variable, x1 of tau. Okay, what this one called? Tau. x1 of tau, x2 of t minus tau into d tau. Okay, in this formula, d tau means tau is the variable. So tau is the variable and t is the constant. Okay, here so many members get confused. Here d tau is the variable and t is the constant. Okay, remember that t is constant, tau is variable. Okay, very, very important. Tau is variable, t is constant. Okay, now first problem. What is the first problem? X1 signal is given, x2 signal is given. Now we have to convolute these two. That is that we have to mix these two signals and find the resultant signal. Okay. Here x1 is in place of x1. We put in place of x1 we have t. Okay. In place of x2 also we have t. Okay. Here when our convolution, in place of t, replace with tau. Okay. First of all, you have to replace with tau. See here, minus infinity e power minus 2t. So e power minus 2 tau. Okay. E power minus 2 tau. What is next point? U of t. U of tau. Okay. U of tau. Next, this is completed. Okay. In this formula, first one is completed. Next, x2. In place of second signal, what we have to put in place of t? T minus tau. Okay, in place of t, you have to put t minus tau. So here e power minus 4t in place of t, t minus tau. So e power minus 4 in place of t, t minus tau. Next, u of t minus tau d tau. Okay. Next, Next, u of tau. Already we have to write a exam. You have to write in exam in this manner. Okay, that is u of tau is greater than 0. U of t minus tau also greater than 0. Here greater than 0. Here greater than tau. So multiplication here. What is the amplitude value? That is height value 1. Here what is the height value 1? So here 1 into 1 1. Okay, 1 into 1 1, and this value is greater than 0, and this value also greater than 0. So this infinity will be converted to 0 to infinity. Okay,
ఈరోజు ఐదు
so
రేపు ఐదు
వినండి. So minus infinity to infinity is converted to 0 to t. Okay, so 0 to t, 1 into 1 1. So what is the limit? Minus infinity to infinity changes to 0 to t. Okay, always in convolution this is the concept. 99% this is the concept. Okay, limits are changed to 0 to t only. Okay, now in place of u of t, what the value? 1. So 1. In place of u of t minus 1, what the value? 1. So in place of u of tau 1, u of t minus tau also 1. So what is the remaining terms? E power minus 2 tau and e power minus 4 into t minus tau. Okay, now multiplication in these two. Okay, in these two, e power minus 4t. Okay, e power minus 4t, e power minus 2t రెండు ప్లస్ అయితే ఏమవుతుంది? How much this value? Minus 2 tau minus 4t plus 4 tau. Okay, minus 2 tau plus 4 tau. How much value? 2 tau. Okay, what is the remaining value? Minus 4t. Minus 4t. Already we know t is the constant value. Okay, here t is the constant value, so this is taken outside. E power minus 4t taken outside. So 0 to t, e power 2 tau. E power 2 tau is e power 2 tau is e power 2 tau by 2. Okay, upper value is t. So suppose in place of tau, upper value is t. Upper limit is t, e power 2t. Lower limit is 0, e power 0 1. Now multiply. Okay, multiply. Now e power minus 2t, e power minus 4t. Okay, e power minus 4t. Last, at last, okay, after last formula we have to write u of t compulsory. This is very very important. Okay, into 1. In place of 1 we can write u of t. Okay, this is very very important. Without u of t, this problem will be wrong. So in place of into 1, in place of 1 you write u of t. Okay, yeah, follow అవుతున్నారా?
ఎస్ సార్.
ఓకే, ఈ కాన్సెప్ట్ ఒకటి అర్థమైతే సెకండ్ యూనిట్ లో కన్వల్యూషన్. ఓకే, సెకండ్ యూనిట్ ఇఫ్ యూ అండర్స్టూడ్ దీస్ కాన్సెప్ట్ ఆఫ్ కన్వల్యూషన్, ఓకే, యూ కెన్ అండర్స్టాండ్ in second unit, third unit, fourth unit, and fifth unit. So this is the model. So this is called, that's why I called this is a model. Okay, from second unit, third unit, fourth unit, fifth unit, any problem, this is the model. Okay, next, second problem, same concept, second problem. Okay, here in place of t we put a tau. In place of u of tau, in place of t, u of tau. Okay, next here in place of t, see here same signal, but here concept is different. T minus tau, u of t minus tau. Okay, u of tau in place of u of tau 1, u in place of u of t minus tau, that is 1. Okay, see here 1 1. Minus infinity infinity changes to 0 to t. Okay, 0 to t into put tau multiplication and find the integration. Okay, now find the integration. Okay, after integration, t square by 2 minus 0, t cube minus 3 by 3. Okay, now t square into t cube. Okay, t cube by 6. Okay, at last what we have to write? Into u of t, t cube by 6 into u of t. Okay, next see here cos t. Okay, In place of cos t, you have to write cos tau. In place of u of t, u of tau. For second function, in place of t, we have to write t minus tau. Okay. So u of t minus tau. U of tau, u of t minus tau. This value will be 1. Okay. So minus infinity infinity limit changes to 0 to t. So 0 to t. Okay. Here 1. What is the integration of cos t? Sin t. 0 to t. Okay. So sin t. Here it is tau. Okay. Sin tau. In place of tau, t. Sin t minus sin 0. Sin 0 already we know that is 0. Okay. So sin t. Okay. What you have to write here? A mistake is there. What is the mistake? In place of sin t, you have to write sin t into u of t. Okay. This is the model 4. Next, model 5. See here, model 5. What do you say about model 5? What we have already discussed? Model 5 means differential equation. Okay. Whenever differential equation is there, that is continuous system. When it is difference equation is there, then it is discrete system. Okay. Now it is model 5. Model 5, that is continuous signal. Okay. Whenever it is differential signal, differential system, then it is called continuous. Okay. So this is the differential equation. This concept is very, very important. Now we are in second unit. Okay. Now we are in a second unit. Convolution is second unit and this concept also second unit. So between these two problems, one problem will come. Okay. ఈ రెండు ప్రాబ్లమ్స్ లో ప్రాబ్లం వస్తుంది సెకండ్ యూనిట్ నుంచి. ఓకే. సో నౌ in second unit, first concept is convolution, second concept is impulse response. Okay, what is the second concept? Impulse response. These impulse response is very, very important in total subject. Okay, in total subject, these concept is very, very important. Previous problems లో కూడా స్టేబుల్ అన్స్టేబుల్ చూసాం కదా. Okay, at that position also we calculated this impulse response. Okay, now we are calculating impulse response. In third unit we will calculate impulse response, fourth unit impulse response, fifth unit impulse response. So each and every topic, impulse response is very, very important. Okay, in these important topics, the most important is second unit and fourth unit. Okay, these impulse response is mostly important second unit and fourth unit. Okay, so these impulse response is mostly important in unit 2 and unit 4. What is unit 4? Frequency response. Okay, here topic is frequency response. Okay, so in topic frequency response, we have to calculate h of omega. Okay, h of omega is called frequency response. After frequency response, we will calculate h of t. Here h of t is called impulse response. Okay, very, very important. Okay, next, already I given a PDF textbook, fundamentals of signal systems by Benoit. Okay, Benoit textbook is there. In this textbook, page number 126, example 3.6. Okay, now this is the equation. In this equation, what we have to find? Impulse response. Okay, impulse response from the differential equation. Okay, step 1. Once wait. Example 8. Okay. Okay. Here step 1. Here what is the step 1? Let x of t is equal to u of t. Okay. Let x of t is equal to u of t. What is u of t? Here u of t is called a step signal. Okay. Here u of t is called a step signal. This is very, very important. Okay. Why you are taking step signal? When step signal is differentiated. Okay. d by dt of u of t is equal to delta of t. ఏమైనా ఫాలో అవుతున్నారా?
ఎస్ సార్
ఎస్ సార్
మనకు ఫార్ములా తెలుసు.
Yes, sir.
ఏంటది? మనకు ఫార్ములా తెలుసు. ఫస్ట్ లో చెప్పుకున్నాం. ఎలిమెంటరీ సిగ్నల్స్ ఇన్ ఎలిమెంటరీ సిగ్నల్స్ డెల్టా ఆఫ్ టీ. చూడండి ఇక్కడ రాస్తాను. డెల్టా ఆఫ్ టీ. ఓకే. వెన్ అవర్ డెల్టా ఆఫ్ టీ ఈస్ ఇంటిగ్రేటెడ్. ఇదంతా ఇంటిగ్రేషన్ లో చెప్తున్నాను. Integration. Okay. Delta of t is integrated. Then you have u of t. U of t is integrated. Then we have r of t. R of t is integrated. We have p of t. ఇప్పుడు రివర్స్ కండిషన్ వెళ్తే differentiation. When p of t parabolic is differentiated, we will get a ramp. When ramp is differentiated, we will get a step response. When our step response is differentiated, we will get a impulse response. ఈ ఫార్ములా గుర్తుందా?
ఎస్ సార్
Okay. When our impulse is integrated, we will get a step response. When step signals are integrated, we will get a ramp signal. Okay. When our ramp signal is integrated, we will get a parabolic. Okay. So when delta of t impulse is integrated, we will get a u of t. When u of t is integrated, we will get a r of t. When our r of t is integrated, we will get a p of t. That is parabolic. Okay, the integration. In this direction, integration. Now reverse direction, differentiation. Okay. Now this direction, differentiation. Parabolic is differentiated, we will get a ramp. When ramp is differentiated, we will get a u of t. That is step. Step is differentiated, delta of t. Okay. This sequence guttundga. For that one, we are taking a step signal. Okay. Why step signal? But here calculating impulse signal. Whenever step signal is differentiated, we will get a impulse signal. Okay. Whenever step signal is differentiated, we will get a impulse signal. అందుకని చెప్పి ఫస్ట్ ఏం తీసుకున్నాం? స్టెప్ సిగ్నల్ తీసుకున్నాం. స్టెప్ సిగ్నల్ తీసుకుని ప్రాబ్లం చేసి లాస్ట్ లో ఏం చేస్తాం? ఇన్ లాస్ట్ విల్ డిఫరెన్షియేట్ ది వాల్యూ. See here. See here. We will get here step response. Okay. Whenever we get step response, we want a impulse response. Okay. Impulse response is the differentiation of step response. Okay. Step signal ni differentiate చేస్తే మనకి impulse response వస్తుంది. Okay. ఈ ప్రాబ్లం వెరీ వెరీ ఇంపార్టెంట్. పైగా సెకండ్ యూనిట్ లో రెండు మోడల్స్ ఉన్నాయి. ఫస్ట్ మోడల్ ఏమో కన్వల్యూషన్ కంప్లీట్ అయిపోయింది. సెకండ్ మోడల్ ఈ ఇంపల్స్. ఓకే. ఓకే. Now see here. Step 1. Step 1, what we are taking? Step signal. Step signal u of t. Okay. U of t. Now we have to calculate characteristic equation of characteristic polynomial equation. Okay. Here this is the equation. In this equation, this is called a characteristic equation. ఇది దీనికి లాప్లాస్ అప్లై చేసాం అనుకోండి. Whenever Laplace is applied, okay, d square by dt square. Whenever Laplace is applied, then it is called s square. Okay. So s square into y of s. Y of s కామన్ తీసేస్తే ఇక్కడ s square plus 3s plus 2. Okay. s square plus 3s plus 2. Okay. ఈ పాయింట్ అర్థమైందా?
ఎస్ సార్
Okay, how you got a characteristic polynomial? When we apply Laplace, square means s square. Okay, cube means s cube. S power 4 means s power 4. So here d square means s square plus 3s plus 2. Okay, this is the characteristic equation. After getting characteristic equation, okay, equate to 0. Equate to 0 and find the factors. Okay, what are the factors? The factors ఏముంటాయి? S plus 1, S plus 2. These are the factors. Okay, easy కదా? Factors S plus 1, S plus 2. Okay, now see here, ఎలా find out చేసిన ఇక్కడ రాసినాం. How I find it? This is the procedure. Laplace transformation of this one. Okay, apply Laplace on both sides. Now s square y of s plus 3 into y of s plus 2 into y of s is equal to x of s. Now y of s is equal to s square plus 3s plus 2 is equal to 0. Okay, now this is called a characteristic equation. Characteristic equation always lies in the denominator part of the transfer function. Okay, what is the transfer function? Already we know transfer function is the output by input. Okay, see here, output by input. Output by input is equal to 1 by s square plus 3s plus 2. So in this transfer function, characteristic equation or characteristic polynomial is denominator part should be equal to 0. So this part is equal to 0. So after factorizing, x plus 2, s plus 1 is equal to 0. So s is equal to minus 2, s is equal to minus 1. Okay, whenever s is equal to minus 1, s is equal to minus 1 and minus 2, for this equation, for this second order differential equation, the solution is here homogeneous solution. Okay, we have two solutions. One is homogeneous solution and second one is a particular integral. Okay, so the homogeneous equation is a1 into e power minus 2t and a2 into e power minus t. Okay, you got minus 2, so minus 2t minus 1 minus t. Okay, second order ki ఇదే ప్రొసీజర్ ఇంకా. Next, already we discussed about the complete solution. Okay, so here complete solution, so here for complete solution is equal to homogeneous solution plus particular integral. Okay, so see here complete solution is equal to homogeneous solution plus particular integral. Okay, homogeneous solution ఎలా వస్తుంది? is equal to 0 చేస్తే వస్తుంది, ఆల్రెడీ క్యాలిక్యులేట్ చేస్తాం. నెక్స్ట్ particular integral is equal to k. Okay, so x of t is equal to 1. ఇక్కడ వాల్యూ వస్తుంది సెకండ్ ఆర్డర్ డిఫరెన్షియల్ ఈక్వేషన్ కి. సెకండ్ ఆర్డర్ డిఫరెన్షియల్ ఈక్వేషన్ y of particular integral is equal to k. Okay, so ఇక్కడ ఏమవుతుంది? put y of t is equal to 0, y of t is equal to 0, y of t is equal to 0, y of అంటే డిఫరెన్షియేషన్ ఏమవుతుంది? y of t is equal to ఇక్కడ వాల్యూ ఉంటే దీన్ని డిఫరెన్షియేట్ చేస్తే 0, మళ్ళీ దీన్ని డిఫరెన్షియేట్ చేస్తే 0. ఓకే, సో x of t is equal to 1. ఇక్కడ x of t, how you got x of t is equal to 1? Because already we taken in step 1 x of t is equal to u of t. Already we know u of t is the step signal, that is value is 1. Okay, so u of t value is 1, so put here 1. Okay, y particular is equal to 1 by 2. Okay, when our second order differential equation is given, this is the procedure. Okay, ఇదే procedure ఇంకా, there is no other procedure. Okay, now we find the value y of p is equal to 1 by 2. Okay, first ఏమనుకున్నాం? the value is some constant. Okay, some constant అంటే differential equation ఎలా ఉంటే the value is some constant. Now we find the constant value. To find the constant value, we are applying initial condition. Okay, what is the initial condition? y of t differential equation is 0, y of t is a particular integral. Okay, x of t is equal to 1. So this is the initial condition. For initial condition, we got y of p is equal to 1 by 2. Okay, now substitute these two values here. Okay, homogeneous solution and a particular integral. What is the homogeneous solution? a1 e power minus 2t plus a2 e power minus 2t plus 1 by 2. Now we don't know the value of a1 and a2. Again, we'll apply initial conditions. Okay, initial condition, that is y of 0 minus. So first differential equation, first differentiation becomes 0. Y of 0 minus is equal to 0 at t is equal to 0. Okay, so substitute the value. Okay, substitute the value. We have ఇందులో substitute చేస్తాం. We are substituting in this equation, that is equation 5. Okay, we are substituting in equation 5. We are substituting in equation 5. Y of 0 plus is here e power 0 1, e power minus 0 1 plus 1 by 2. Okay, now differentiating this equation. Okay, differentiating equation 6. So this equation 6 is equal to, this is a1. Okay, so we are differentiating equation 5. Sorry, differentiating equation 5, previous equation. What is the equation? This is the equation. This is the equation. Okay, on differentiating equation 5, we will get a minus 2 a1 e power minus 2. Okay, minus t minus 1 a2 e power minus 2. This is constant 0. So minus 2 a1 minus 2. Okay, from this already we know this value is 0. Okay, from initial condition this value is 0. So from equation 6 and 7, equation 6 and 7, on solving, a1 is equal to 1 by 2, a2 is equal to minus 1. Substitute the values here, 1 by 2 e power minus 2t minus e power minus 2t and u of into u of t. This is the step response. Okay, now we will got the step response. Next we have to find the impulse response. Okay, this is the step response. Now we have to find the impulse response, that is step 3. For impulse response, step response should be derivated. Okay, apply differentiation. Apply differentiation. Okay, minus 2 by 2 e power minus 2. Okay, minus 2 by 2 e power minus 2t minus of minus plus e power minus t plus 0. Okay, e power minus t minus e power minus t into u of t. U of t is compulsory. Okay, finally impulse response of the second order system is, second order system for t greater than 0 is obtained. Okay, this is very, very important problem. Okay, next also same procedure. Okay, in next problem, first we have two solutions here. See here, we have two types of solutions. First is directly impulse response is find. Okay, we will find the directly impulse response. Okay, solution 2 is, first we take step response and later we find the impulse response, like the previous problem. Okay, both are okay, but this process is very, very easy. Okay, step response is very, very easy. Okay, this is the model 5. Okay, same procedure for the second problem also, same procedure. Okay, same procedure, y of t 1 by 6. We will have one equation. Okay, same for this equation, put s of 0 minus is equal to 0 and differentiating this one and find the value. Okay, we will get two equations. Okay, on differentiating, this is the value, we will get two equations. Okay, and for two equations we don't know the value of a and b. Find the value of a and b and substitute the values here. Okay, and step 3. Here, what is step 3? This is step response. Okay, finally you will get a step response. After getting step response, in step 3 we will differentiate the step response to get a impulse response. Okay, impulse response, and here we differentiating the impulse response. Okay, and this value, this is the final value, and we have to write u of t. Okay, here we write, see here, impulse response is the differentiating of step response. When our step response is differentiated, we will get a impulse response. Okay, this is the model 5. From here we will complete the model 5 tomorrow evening. Okay, tomorrow evening maybe we'll start at 6 o'clock. Okay, That is the next 5 models.
Okay, sir.
Thank you, sir.
Okay, thank you.
Okay, sir. Bye, sir.